Alrighty, we are back from lunch, and boys, let's get going with this. Let me adjust this just a little bit. Okay. So we went over all those specifics of limits. It's definitely easier to grasp when you're doing as x approaches a certain value. But today we're going to talk about the limit as x approaches infinity, which is where we look to the right. Yes, very good. And the limit as x approaches negative infinity, which is where we look to the very good. Nice. Okay, so let's talk about some situations as x approaches infinity and negative infinity. And really, okay, so this says x to the 8th. Like, with your arms, can you show me what the graph of x to the 8th looks like? Very good. So Camille did this with her arms, very basically. It may have more of a flat base there, but we're not going to be critical of anybody's base today. Anyway, so the limit as x, the limit, sorry, I'm doing logs and natural logs in algebra 2, so sometimes I'll go to write limit and I'll do log or whatever. The limit as x approaches infinity of this would be, since it is going to go up infinitely high, then what is the limit of that y value? It does not exist. Very good. So it's literally a limit. Okay. What about to the left? Okay, so same to the left. So the limit as x approaches negative infinity would not exist either. What about x to the 3rd power? Very nice. She did this with her arms. So to the right, we are going to infinity. To the left, we're going to negative infinity. So therefore, the limit does not exist. I don't want to be pretentious and write it out again. Yeah. You're sensing what?
A pattern.
Yes, absolutely. Now, let's talk about this one right here. This is kind of extreme. But it's basically going to be a variation on the graph of 1 over x. Okay? Not exactly like it, but can you imagine that it is going to have a vertical asymptote at 0 and a horizontal asymptote at 0, and it's going to look something like this. However, this is way off scale because I would imagine that it's going to be like creepily steeper than just 1 over x. But it's basically the same behavior. You shake your head. Did you graph it?
Yeah.
Yeah? And can I see...
basically, you're a genius.
So basically, I'm a genius, right?
Yeah.
Is that what you're saying?
That's what I'm
fantastic. Okay, so the difference in her graph, actually, if you want to show, it comes down way quicker and it approaches that horizontal asymptote really quickly, okay? But basically, so the purple is 1 over x, and the red is 1 over x to the 7th. Hold on, let me make this a little bit lighter. So that's basically the behavior. So
if it was x, if it was 1 over x to infinity, then it would reach 0.
Yeah.
actually, even right here, the limit as x approaches infinity, let's do to the right first, would be what? Right. It would be equal to 0. It is getting closer and closer and closer and closer to that asymptote to where when you graph it, even on your fancy color edition TI-84, right? Or if you graphed it on Desmos, which is actually even more versatile than that graph right there, you would see that it is like you can barely tell the difference between the graph and the x-axis. Am I right? Like it looks like it's just totally landing. It's not. Because if I go, let's plug in a big value for x, like 10. Not very big, but 10 to the 7th power is huge. So it is literally going to be 1/10,000,000th. Bless you. That is going to be the value of y at that place. It's still not 0. Now, honestly, it's like damn near 0. Like it's as near to 0 as you can get without actually touching it. But that does mean that the limit is equal to 0. And the limit as x approaches negative infinity would also be 0. Okay? Yes?
Does it matter for like if it was like x to the third or x to the fifth? Because it would be the same like outcome at the end.
Correct.
But there's just more humps in the middle.
Actually, let's go down here to 1 over x to the 6th. Do you all know basically what that's going to look like?
Is it like something another one?
We are going to have a vertical asymptote. We are going to have a horizontal asymptote at 0. And it looks, Camille, I want to double check. Does it look like this?
I made it big.
Full. Yep.
Yeah.
Now,
Very steep.
so, by the way, it looks very similar. Okay. Admittedly, the left-hand side and the right-hand side should look exactly alike. Because whether you square a negative number or square a positive number, you're going to get the same value. That's why they both exist up here, because that would be, I'm sorry, not square. Raise it to the 6th power. Same thing. And so what is the limit to the right? 0. So as x approaches infinity, the limit of f of x is 0, and it is 0 over here as well. Right? Do I have to write everything out, or are y'all good? Okay.
Absolutely.
What about x to the 5th?
That's the same as like the second one.
Correct. Very good. It would also look like this. Actually, maybe even more curly than that or whatever, but it would not exist because it is going to infinity. Okay? And what about x to the 10th?
It's the same as the first one.
Right. Does not exist because it is going to infinity. There literally is no limit to the y value. Okay? So, what we just did right here is this right here. Okay? If you have x raised to a certain power, then the limit to the right is 0. The limit to the left, it depends on whether the function is even or odd. So that makes sense because of the difference between these two graphs. The limit as x is raised to the negative n power, which is really like this example right here. This is like x to the negative 7th power. Would be 0 to the right, and it'd be 0 to the left. Does that make sense? That's straight from a textbook, and that's kind of a funny way to write it, but anyway. So, let's talk about the other situations.
Can you go back to that?
Yes.
So the limit is x approaches infinity and then x equals infinity. So that's for positive infinity. What does it mean by for negative infinity down there?
Down here. This is like 1 over x to the 7th, or x to the n, okay? And so it would be 0 because it has a horizontal asymptote. Yeah. Okay, so what if we have a function on top of another function, like the horrific rational function that we have right here? Actually, okay, so, yeah, I know, right? It's disgusting. Actually, I don't even know. Can the bottom be factored? I haven't looked at this in a while. 5 and 1? No, it can't be factored, can it?
Oh no.
Oh, it's x to the 5th. Oh, gosh. Ah, yeah. So, like, I can't even factor that and find where my function has vertical asymptotes. Well, that's okay because it is asking me the limit as x approaches. This is asking two different questions. What is the limit as x approaches infinity, and what is the limit as x approaches negative infinity? And do you know the answer? How do you know the answer, Ben?
You just kind of put in really big numbers and you just kind of...
Okay, that is actually, to be honest with you, direct substitution is what Ben is referring to. Like, put in 1,000,000, okay, square it, multiply it by 20, and then subtract 3 times 1,000,000, and holy crap, right? Basically, you will have a big number over a really big number. Does that make sense?
Yeah.
Oh, is this the letter I wrote? Can I just make sure it's the letter I wrote? I mean, anytime you sign something, you want to make sure it's what you actually wrote. You know what I mean?
I can see it, but I never thought about it.
This is the fourth time I've done this today.
I can only do that.
You're fine.
Ow, stop.
Like that? Is that okay?
Yeah.
Awesome. Yep. Yes.
Can you just use the rules for the degree?
We are going to use the rules, and we're going to go back through those rules at the bottom of our page here. But in general, the degree of the top is smaller than the degree of the bottom. Do y'all remember what that is?
Oh, it's crap, what was it? The slant?
Nope.
No, not the slant.
That's the other way around,
Yeah.
though. So we'll get to those situations here in a second. When the top is smaller in degree than the bottom, then you have an automatic horizontal asymptote at y equals 0. Okay? So the horizontal asymptote at y equals 0. Now, I don't care. I don't know for this function. Maybe Camille has graphed it. Of course she has. Anyway, maybe Camille has graphed this, and I have no idea whether it looks a lot like this one or a lot like this one, but I don't care because there's a horizontal asymptote, and by definition of a horizontal asymptote, that means as the x values get infinitely large, it gets closer and closer to 0, but never actually touches it. It may do that from the top, or it may do that from the bottom, but 0 is 0, right? Love is love, and 0 is 0, right? Infinity is not necessarily infinity, though. Does that make sense? Anyway, Also, to the left, it is doing the same thing. I don't know whether it's coming down or like going up as we move to the left, but I know it's approaching 0 because that is the definition of what happens with a horizontal asymptote. Yeah?
What if it's one of those graphs that goes through the asymptote?
No. Okay. It will, but that will happen in like the middle, but that will never happen as x approaches huge numbers to the right or huge numbers to the left.
If you have something like that, we have to do like a synthetic division or something.
I wouldn't even know because it just doesn't happen. When you have a horizontal asymptote, let me make sure you understand what he just asked. When we had horizontal asymptotes, something really disgusting happened, and sometimes the graph would cross that asymptote, right? It would look like your dog has gotten out of the fence, right? Just broke right on through it. That will happen for very small values of x, but not for very large values of x. So you would have to investigate the details of that function for the limit as x approaches 2 or the limit as x approaches 5 or whatever, but not for infinity. This, by God, is going to approach 0 way out there and way out there.
Wait, so it's not going to be where, because I remember one of them was like,
That's a funkified well, no, that would be natural log or log.
yes, like, I mean,
So we
it
can-
would go through the asymptote and it goes and then out that way. Out that way.
If it has a vertical asymptote, it would change that, but not out in infinity.
Alright.
So it would still be approaching y equals 0. Yeah. Okay, so do you remember what happens here? So this has a horizontal asymptote at what? 3/7. Y equals 3/7.
Oh, go.
Why? Because the top and bottom degrees match. So we do leading coefficient over leading coefficient. Okay.
Oh, no.
Wait, what did you say?
We do leading coefficient over leading coefficient when the degrees match. And by the way, if you want to make a note of that, if the top degree equals the bottom degree, then your asymptote is y equals the leading coefficient over the leading coefficient. Are you all okay with me not spelling that out? Well, there'll be a link to this video, so if you don't know what that means, you can go back and watch it.
Leave a comment.
Okay, but this one, n, or the degree of the top, is way bigger than the degree of the bottom.
That's the slant asymptote.
Okay, actually, technically, this one will not be a slant.
Okay.
It will, in general, be an oblique asymptote. It won't be horizontal. It will be something other than horizontal. And what that depends on is the difference in these degrees.
Oh,
What is the degree difference?
even.
Odd.
What?
We're not even.
Very good.
Four is my favorite.
So 7 minus 3 is 4. And by the way, the leading coefficients are positive. Okay, so I don't have anything weird going on. If you all want to know, this will have a vertical asymptote, and it will have an asymptote that basically makes an x to the 4th pattern. Now, without graphing this on my graphing calculator, like I said, I don't really want to. It's disgusting. Okay. So my graph might look like this Oh God, I've done this before. It kind of looks like a couple of butt cheeks. But anyway, it might look like that. Or, and this is really creepy, it might look like this.
Oh.
I like that.
Depending on what all's going on in the function. I actually don't know. I actually do not know which one this would look like, but I do know the limit as x approaches infinity would be infinity, so it does not exist. The limit as x approaches positive infinity, oh sorry, that's negative infinity. This is positive infinity. But the limit does not exist.
Mine looks like
Yeah, mine, what is
Numerator and denominator.
numerator.
Right.
Why,
Yes.
I graphed it and it looks like this.
The red one or the black one?
Green.
Oh, and there's another piece. Okay, so mystery solved. This graph actually looks.
Not as
Both?
valid as we thought.
Like both?
What is,
Ew, what the heck?
you're so funny. And it had like a thing up here, and it would probably have a thing down here.
Yeah.
But anyway, that's this one. You did graph this one? Or did you graph this one?
I graphed that one.
This one, the top one?
Yeah.
Okay.
Wait,
2 or 4?
I graphed 2.
Okay, gotcha.
The one we're doing.
Yeah.
But for crying out loud, it's going to be either infinity or negative infinity, at which point we would say does not exist. Now, this one, the degree of the top is smaller than the degree of the bottom. What did we say?
0.
Right. This has a horizontal asymptote at y equals 0. And so therefore the limit as x approaches infinity would equal 0. Or negative infinity. Actually, it doesn't matter which one it asked us. Again, what do you think this fourth one is going to be?
Slant. No.
It's going to be oblique, but it's going to have an odd
Oh.
degree. And so, therefore,
It does the
I don't know, but the ends are either going to do this or they're going to do this. Because the difference between them is odd. So they're doing the disco. That's right. So whether it's pointing up or pointing down to the left or to the right, guess what? The limit does not exist. Right.
So if it's got the like the top is bigger than the bottom, then it's never going to exist. Or infinity.
So if the top is bigger than the bottom, and the difference between those is an odd number, then I'm going to either have like either this situation or this situation in general. So it's either going to be negative infinity or positive infinity, whatever the limit as x approaches positive or negative infinity of f of x would be equal to, well, would not exist, D-N-E. Thank you. I almost wrote the wrong thing. If it is even, then it's either going to basically look like this or basically look like this,
So it's
which is either infinity or negative infinity, and in which case the limit does not exist. Now, what if the top is smaller than the bottom? Those are our favorite graphs, is when the degree of the top is smaller than the degree of the bottom. And, by the way, if you were like impressed at me graphing the ones on the other side, y, or 1 over x to the 6th versus 1 over x to the 7th, it is literally only because I was using limits in my head and they had an automatic horizontal asymptote at y equals 0. So what's this limit right here? 0. What is this limit right here? Okay, I just kind of want to trick you a little bit. Would this end up being positive infinity or negative infinity? It would be negative infinity. But since that is not a limit, then we say the limit does not exist. The limit does not exist. Has anybody not seen Mean Girls, or at least that clip from
I
it?
don't remember that.
The limit does
I
not
remember
exist.
every other part of the movie.
It's at the very end when she wins the quiz bowl or whatever.
Yeah, it's been a long time since I've seen it. The last time I saw it was when I was like in a plane and that was one of the movies.
Oh, and you can't keep up with what's going on in
It's
there.
in play.
Yeah.
It didn't bother me that much, but my brother was like looking over like, what are you watching?
The limit does not exist. Does that make sense?
We should just watch that.
Harry, I know Harry was about to start on the Delta math stuff.
I don't think Harry's on the Delta Math.
Oh, he's not?
I already did the Delta.
Oh, okay, yes. And were there any tricks?
There are a few tricks.
Did anything stump you?
No.
No.
If n equals m, it's A over b. If n is less than m, it's 0. Otherwise, it's determined by whether the coefficients are even.
Very good. That is my personal email address. So yes, everybody knows my personal email
His
address.
last name would be gone, honestly. The guy was like,
That would be nice.
why does he live like that?
You know what's really fun? Is
You know what the-
What?
You know how like they
What?
do sometimes like the people we associate.
Yeah, I
with
did all of
portrait,
the.
they're like portraits made up to like their long
I
back.
don't really
Yeah.
feel like
Yeah,
I'm
we just, like,
explaining
made it
how
up.
it'd be that.
You have no idea what they look
We just
like.
made up how different she looks.
So I found
Actually, let me
You know, I
stop.
knew this guy. I had
The